Hi, I'm Patrick O'Grady. I'm the technology reporter for the Phoenix Business Journal. I'm here with Pat Clausen and Lou Mention. We're talking a little bit more about whitelisting today. Specifically, we're talking about antivirus and whitelisting and how they marry up and make a pretty good combo. Pat, you mentioned earlier about blacklisting. Can you give a little description about what that is and what some of the challenges are with it today?
Yeah, absolutely. And most of our viewers are going to be tech buyers, and you guys live and breathe this every day. But to be deliberate about it, the antivirus or blacklisting technology really is a reactive technology that deals with some form of malware that's been identified, and then the vendors create a signature that they push out to their customers, and that signature is then pushed out to the machines, and it blocks that bad form of malware. One of the things that we've seen happen, though, over the last few years, there was a period of time where the effectiveness of antivirus and the number of unique pieces of malware that were being released were pretty close to each other. And your ability to respond quickly to it was one thing. But what's happened recently, this year alone, we're up to 1.5 million unique pieces of malware each month that are being identified. And that's the stuff that's publicly identifiable. So you have this massive escalation in terms of the pieces of malware to a point where the antivirus technologies can't keep up with it. Logically, physically, can't keep up with it. And then you also have the other forms of malware that are never really made public. They're very, very specialized pieces of nasty software that are written custom to go penetrate your network and extract things. And no antivirus company is going to get that on their radar. Furthermore, we've also identified that very often a vulnerability that's been identified, or even a piece of malware, it's been out there in the wild for a period of time before it's ever identified in the first place. So you've got this thing being out there used against you and mining you for data for a period of time. So really remembering that blacklisting on its own is reactive, and you have to have known what the problem is so you can build a plug for that problem. And one of the biggest issues that we see today in the marketplace is the massive ramp in terms of the numbers of pieces of malware and antivirus companies' ability to keep up with that and the unique forms of malware.
Now, that said, does that mean that everybody should go out and replace their antivirus with something else, whitelisting?
Absolutely not. And I think that's one concept we want to very effectively get across to people. First of all, antivirus is an audit requirement. In most places, we've got to have it. Is it the be-all and end-all to keeping our endpoint machines clean today? No, it's not. It's because of that gap we just mentioned a few minutes ago. So what we're starting to see, for example, Lou mentions intelligent whitelisting, is a marriage of this whitelisting and this blacklisting to create not only white and black, but also gray. So some flexibility and ease of use in terms of IT administration, and something also that doesn't create a point of frustration for the end user. Old whitelisting was no you can't, no you can't, no you can't, so much so you heard it made you go crazy, right? No matter what you tried to do on your machine, it would not allow you to use a form of software that wasn't approved by IT. Intelligent whitelisting really kind of leverages the blacklisting and the whitelisting and in the integrity of software manufacturers to allow a greater form of flexibility for the end user as well as the IT administrator.
Okay. A little bit more on that. When they're working together, what do you see as the best marriage of how they work together in a different kind of business environment?
Really, intelligent whitelisting, when it's married, the marriage of application control or whitelisting and blacklisting, and for that matter, patch remediation as well, really allows you, with a single agent and a single set of policies, deploy security as you want it, by machine or by user or by anything Active Directory can serve up to you within your enterprise. You might say that I, CEO, might just be traditionally blacklisted on my machine. Now, I might have mission critical servers. I might also have some new employees. I might also have developers where I want to accept zero risk on their machines, and they might be very tightly application controlled. Now, in their environment, that tightly application controlled, they're still going to get their updates for WebEx because we have them in a trusted updater status without creating a logjam for IT. They're still going to get their Adobe updates because that's authorized software and we know them, and that'll happen automatically without creating a requirement for IT to get involved. They're going to get their patches on their machines because it's a trusted process and we know the authors of the patches. Really what they're not going to be allowed to do is skate outside of that trusted realm, that trusted cocoon, and have a possibility of downloading software that could infect a machine in any way, shape, or form, because we're just going to keep them in that trusted world. The other thing to remember is you can move that dial from that very tightly whitelisted to just the simply blacklisted or anywhere in between it based on anything Active Directory can serve up to you. So ultimate flexibility. You don't lose anything. You have your enterprise antivirus, so status quo is established. And then you're able to ratchet up security on the machines and the groups that you think are most important for you to dig into within your enterprise.
Gotcha. Now, how is intelligent whitelisting different from just the standard application whitelisting that we had talked about earlier?
It really is about its interaction with different technologies, and that's key. When we first sought out to do this, I mean, as a standalone today, we have application control, which is a very traditional whitelisting technology. It's the most deployed in the world. It's very exciting, but it's also very rigid. And on its own, if it doesn't have interaction with other technologies, it is a manually updated whitelisting technology that's exceptionally secure. So what we've done is we've created 3 or 4 points of interaction with other technology. For us, intelligent whitelisting is really the marriage of the blacklisting technologies or antivirus. It's the application control module and our patch remediation module. So why is that? Let me take you through our view of how this all works. In today's world, when a machine is challenged with a new piece of software, it asks basically one simplistic question. And that question is this software known to be bad? Okay, yes or no. If no, it allows it to move on down. And sometimes it may not know it's bad because it doesn't have a signature that's already been written for it. On the other side, what we've done is we've created a whole new series of questions that our agent asks every time a new piece of software tries to enter a machine. One of those we ask is it known to be bad? Because we need to know the known bad as a part of the process. The second question we ask is it known to be good? One of the great advantages of our intelligent whitelisting is our endpoint integrity services. Because of our patch remediation heritage, we have a long history of minute-by-minute updates from all the software manufacturers and the operating system manufacturers. So we know this whitelist on a minute-by-minute basis. So our integrity services in the cloud provides our customers with the knowledge of what's good, what's safe, what is hashable, and can be trusted. We have another concept, which in this series of questions we ask is it wanted? We now give our customers the ability to make simple decisions about software that may or may not want to be wanted. We then go through and ask a whole bunch of other questions. We understand the user and the role within the enterprise. We understand not only the publisher, but the path that software is coming to us on. We have the concept of trusted updaters so that we can allow those technologies that we have in our enterprise, as mentioned before, like Adobe or Microsoft, to be able to update automatically without IT intervention. Then we ask 2 final questions. Then this kind of brings patch into the mix. Second to last question we ask is licensing relevant for this piece of software you want to put on your machine? And if it is, do you own the licenses? Is it legal? Right. Always an interesting question. The last question we ask is what is the vulnerability status of that piece of software you're wanting to download? Regardless of who the manufacturer is, over time, every hash, which is what we do with that piece of software, we SHA-256 hash it, every hash becomes vulnerable over time. And what we can provide that no one else on the planet can provide is the ability to systematically apply the patches at time of download. So we always maintain the latest, greatest state for a piece of software. So when we talk about intelligent whitelisting, it really is about putting whitelisting in an autopilot mode. It's allowing users to live in a very trusted environment with a wide selection of software that we have a known good hash for. It allows things like patches to happen automatically without creating an IT log jam as a part of that process. And the end user very rarely knows they're being whitelisted because the sphere of known good software is so vast. So that's what it's about.
All right, Pat, thanks for your time. And this concludes what has been a kind of a top-down look at whitelisting and wrapping up some of the issues involved, including dealing with antivirus, dealing with some of the misconceptions, and how it all began. Thanks for your time, and we hope you've learned something.